My name is Kyle Banerjee, and today I'm going to provide a gentle introduction to RDF, or Resource Description Framework. The first thing I think anyone should do when they're presented with a new acronym or technology that they're told to learn is to ask, why should they even care? And in the case of RDF, it's because it's changing the way libraries operate in terms of how they keep, maintain, and provide metadata and data. And as we provide access to a greater variety of things, you're going to see this influence continue to extend. Now, the reality is that libraries have been concerned with the problem RDF attempts to solve long before RDF became a thing. And in fact, I would argue we're already proposing practical RDF-like solutions before RDF existed. Now, RDF is expressed in XML, but I think that the container that information comes in is not really that relevant. What's important about RDF is it uses identifiers to express things. And in 1995, Michael Heaney wrote an article which I think is particularly interesting called Object-Oriented Cataloging. And in this article, he describes how we're going to use the existing OCLC database and all these thousands of libraries all over the place that have completely different budgets, completely different systems, that some aren't going to replace them for 20 years. How do you get from that system where you have today's systems, people, and metadata to a world where we use identifiers for everything? People often say that imagining having vision is really hard, but it's very easy to manage in the future. The hard part is how to get there. For example, if you want to come up with a new car, it needs to operate on the roads of today and use a fuel source you can actually get to. Otherwise, it will never take off. Or if you wanted, to be able to carry more cargo, everyone knows that wider gauge rails will support more weight. So if you wanted to support more cargo, all you have to do is tear out all the rails, replace all the engines and cars. Oh yeah, you'll have to replace all the shipping containers all over the world too. The hard part is not envisioning the brave new world. The hard part is figuring out how do you get from what you actually have to this future that you've envisioned. And we have this railroad freight problem with our existing. How do we get from our existing metadata and systems to this new world? As I've already said, RDF is a way to express relationships between things and concepts in XML. It's like, what's a relationship? What's a thing? What's a concept? It's anything. A person could write a book. So, for example, a person is an entity, a book is another entity, writing is a relationship. There's a writer. A person is born in a particular year. The person's one thing, a year is another thing, is born in is the relationship. A person could feel happy. And so you can say Jane feels happy. So Jane's one entity, happy is a concept, and feel is a relationship. And what's special about RDF is that it expresses these relationships using identifiers that typically point at other identifiers. So in other words, when we say Jane feels happy, we'll use an identifier for Jane rather than Jane herself, because that identifier can contain pointers to all kinds of other information related to her. And happy can point to all kinds of other things like broader and narrow terms, related terms, and whatnot, rather than encoding them directly. Now, whenever I'm calling them identifiers, you're typically going to hear them referred to as URIs. I avoid the concept because I find that term needlessly confuses people. A URI, Uniform Resource Identifier, all it means is identifier. A social security number is a unique identifier. It identifies a person. It is a URI. Very technically it is. Likewise, a UPC, it identifies a product uniquely. So it is also a URI. There are an ISBN. I know that there are problems with it, but theoretically at least it uniquely identifies a book, and so on and so forth. There are just identifiers. So the idea with RDF is you're using XML to express relationships using identifiers that point at each other. So what's the point of that? And the answer is you can express very, very complicated relationships, and it also simplifies certain maintenance and user functions. For example, let's suppose Library of Congress updates one of their very, very outdated terms. Without identifiers, if you're not pointing to identifiers, what happens is they have to have some way of publishing what changes occurred, and then it's upon all of the libraries to change all the instances of the old form into the new form. And then if they have an authority file, then what they do is they need to update that too, so that the old term becomes a C from. And if everything pointed at identifiers instead, it would automatically be updated as soon as it's updated in the one place. However, it's very important to keep in mind that simply storing identifiers does nothing. So like if you have a record that contains an identifier rather than an author's name, for example, the computer doesn't know what to do with it, not until you tell it what to do. For example, if you took your existing catalog and you said, I'm going to put identifiers where all the authors' names are, what's going to happen is you will no longer be able to search by the author's name. You will no longer be able to see the author's name. You will only be able to search by the search for names if you know the identifier, and then it will only display the identifier. So you have to tell a computer to do stuff. And so whenever you hear about people using identifiers, always remember that somebody has to tell all the identifiers what to do. Very, very important point. I presume that you will also be looking at other explanations of RDF on the internet. Unfortunately, the vast majority of them, you have to already know what RDF is in order to understand the explanation. I would recommend ignoring all of them that talk about the semantic web, triples, models, contain an alphabet soup of acronyms, contain diagrams with things pointing all over the place, or otherwise look like you need a programmer to figure out. Unfortunately, this would also cover well in excess of 95% of the explanations you're going to find. The important thing to understand about RDF, we're going to break things down a little bit more simply in a little bit, is that when you're storing identifiers, what it's really about is linked data, and what all linked data means is you have identifiers that you point to over a network. The important thing to understand about using identifiers that are linked together is you have to have some knowledge base to say what it means. So for example, in the case of a subject heading, somebody somewhere has to say this identifier refers to this subject heading, and it has these broader or narrow terms or whatever, or at the very least, even if it doesn't say that there's any broader or narrow terms, someone has to say what it actually resolves to. And if it points to a person, it has to say which person. The question is, who actually maintains this? And seriously, this is a very serious question, because everyone says, oh, you can have all these namespaces, everyone can maintain it. The question is who? The Library of Congress authority files for names, subjects, and all that kind of stuff, everyone knows it cannot keep up. It's because it's very, very hard. And that's something that libraries have been working on for decades. Although you can make up a new namespace and you can make up a new vocabulary, it's hard to keep it going. And always remember, when you're using these identifiers, if it consults a knowledge base, someone's going to have to maintain it. Many functions that libraries highly value become very problematic in an RDF or linked data environment, because if you're pointing at identifiers, you're no longer pointing at what they are. For example, if you save all your records, you've just saved all your identifiers. You've saved all your identifiers. And if they're pointing at different places, I mean, it's not like you can traverse each identifier, resolve each one of them, and pull it back. That's not a practical thing to do. And so if you try to resolve it later, those identifiers might mean something else in the future, because the records get updated. The service might not be available at all. So yes, archiving is very tricky. Likewise, search. You cannot search for fragments of an identifier if you have to have some way of, not unless you resolve what the identifier points to and create a separate database of that. So, or if you want to see how many records, how many terms follow this pattern, if you're storing identifiers rather than the terms themselves, it makes analysis much harder. So there's a lot of things that libraries do that when you express things in RDF or in linked data, that it's much harder to do. I think it's very important to keep this in mind because people get very excited about these technologies, but there's a major downside. It's designed to solve a completely different problem than many libraries are used to, and so they need to remember that many of the things we've taken for granted no longer work. Another challenge that linked data in RDF have is it's very complicated, and this is at a time when users and staff alike demand simplicity. For example, take the MARC record. It has hundreds of fields. There's all these subfields, indicators, and whatnot, and every system I've ever seen normalizes that. No system uses, they have a definition for all these fields in bib formats and standards, but they always normalize it to make it much simpler. And nobody wants it any other way. Nobody wants to have to define each and every indicator. And RDF and linked data are far more complicated than that. We're not talking hundreds of fields. We're talking, for all intents and purposes, infinite. Millions or billions. And what it doesn't tell what to do with these fields when they find, because you can define any relationship. And when we can't even keep up with MARC, it's not something that just because you can do it doesn't mean that it's a good idea. Let's go back and take a look at what a record might look like in RDF. And so what I have is a MARC XML record, or a portion of one, where you have your 100 field, your 245 contains a title, have a subject field. When we look at the RDF record, we will see that we have identifiers. So like there's a work identifier, rather than the work itself. For the author's name, it doesn't contain the actual author's name, but rather it points to an authority record, so that if I change my name or something like that, it would automatically be updated. Likewise, the subject heading, we're pointing to a subject identifier rather than encoding the subject heading itself. You also notice the namespaces, where we have BF for bib frame, and then you have the RDFs for the RDF syntax, and so that way when it has the namespace prefix, it knows that work means in the context of the bib frame, and not like some musical concept of a work, for example. That's what namespaces do. So this is what a RDF record looks like. Now, if MARC were linked data, and it wasn't in RDF, it would look kind of like this, and this is sort of like what Michael Heaney envisioned, and that is that instead of the author's name, you put your authority record number. Instead of a subject, you put your subject field, and that this is a one way of moving forward. Now, when you hear about RDF, you're going to hear a lot of jargon, SPARQL, turtle owl, triples, FOAF, and all of that information. It just operationalizes RDF. You really don't need to worry about it unless you are a programmer. The OWL stands for Web Ontology Language, and yes, it does not help that you have an acronym where the order of the letters are different than the order of the words. And it's not a language. It's a set of rules for defining ontologies. Like XML is not really a language either, despite its name. Extensible markup language, it's not a language. What it is it's a set of rules for defining markup languages. That's what it is. And likewise, OWL is not a language, but it's a set of rules for defining ontologies. So you're saying, what's an ontology? You can think of it kind of like a thesaurus on steroids. With a thesaurus, you have broader, narrower terms, related terms, so on and so forth. In an ontology, you can have any kind of relationship. For example, you could say a dog has a certain color fur, cake has a certain number of candles, it's made with these ingredients. You can define any relationship you want. It just depends on the ontology. And so the web ontology language what it does is it gives you a way to define ontologies so you can say what relationships apply in a particular case. And so friend of a friend, what it does is it uses OWL, or the web ontology language, to define relationships, and the triples define relationships between two things. Like, for example, you could say Jane feels happy. So Jane is one thing, happy is another thing. Happy is another thing. Feels is the relationship between Jane and happy. City has a population, or contains X number of residents. You have your city, your number of residents, contains is the relationship. And so triples are, you have two things, and then there's part in the middle. SPARQL is the SPARQL protocol and RDF query language. And yes, you have an acronym that contains the acronym itself. This is one of the reasons I'm a critic of the terminology used, because needlessly confusing. All it is a SQL-like language used to query databases. And I know it says it contains triples. It's a query language. And then Turtle, again, we have another acronym which is spelled different than what it represents, and terse RDF triple language. And what it is it's another way to express triples. So you can express triples in XML, but you can also express them in a language called Turtle. And you don't use Turtle to express anything other than triples, as far as I know. But like I said, you don't need to know any of this stuff that just operates RDF. The important things to know is that RDF provides a structure for defining things, just a very broad framework, and OWL, or the web ontology language, defines things and the relationships between them. So don't worry about the other stuff. These are the things. RDF is the structure, and OWL allows you to define things more specifically. To try to relate it more to a library world is that you have a physical data structure, that's XML. RDF is expressed in XML. In the MARC record, we are not talking MARC XML. I very specifically mean MARC binary, because those numbers are not part of the MARC format. You can express anything in MARC. For example, MARC fields do not need to be numeric. You could have a field, the MARC format does contain 3 characters for each one, but there's no reason why they can't be ABC or 3Q5. The bib formats and standards says that what those fields represent in a library context. So it's the MARC binary structure is analogous to the XML, and LRM is a conceptual model for organizing library data, and RDF likewise is a conceptual framework. And on top of that, you have a set of rules. OWL is a language for describing ontologies, and RDA, it tells you how to define content. For example, it will tell you what elements belong in the record. Like, it will say that, encode the creator, and it will even tell you how to encode the creator's name, but it won't say what that is. And then on top, you have bib formats and standards, which tells you that the author's name goes in the 100 field, the title goes in the 245, the Library of Congress subject headings goes in the 650 blank 0, and likewise, after you define the specific ontology, that's where your content goes in the RDF. So this stack gives you an idea of how the components are related. The only reason I'm showing this is because people always want to see what things look like. You don't need to memorize it, but this is what Turtle looks like when you're expressing FOAF. And so it's showing showing some information about me and somebody that. For a SPARQL example, all we're doing is we're querying that FOAF file that we had on the previous slide, where we pull the name and home page out using a SQL type language. Again, you really don't need to know this, not unless you're an actual programmer. And if you're watching this, you'll need to know more before you can use it. The important thing to understand about RDF is that it's, for all these linkages and identifiers and all this kind of stuff. It's just plain text. It allows arbitrary structure. It doesn't tell you what you can put in there. It only gives you a set of rules for defining things, and so you can define things that make no sense. Like you can say what color fur a cake has, and I realize if you leave it out, maybe that does make sense, but you could give like a city could have a surname, it could have a favorite color, water could have a burning temperature. I mean, you can, it doesn't put any limits. That's where the specific ontologies and rules on top come into play. And that's why I've made this other point, is outside of limited domains, it's actually too complicated. When I say a limited domain, when you have things in a conceptual universe, it can make a lot of sense. For example, let's suppose you have a drug interaction database. There's a limited number of drugs, and yes, there's many thousands of them, but at the same time, it's limited, and so you can define them all. They belong to classes. There's certain ailments and there's certain side effects, and these can also be classed. The conceptual universe that these things belong to is well defined, and where you run into problems is when you have an unconstrained universe, like you can't use the universe of knowledge because it's unconstrained. It makes the definitions too complex. Moving forward with RDF, the real question is, what do we really hope to use it for? As we move forward, we're going to run into a lot of challenges. I've already alluded to these. One is your legacy data and metadata, your systems ecosystem. How do you maintain it? Who is actually going to maintain all this information, the systems and whatnot? How do you archive and maintain something that's distributed? Where do you find people that know how to do this stuff? Because if you're even listening to this, it means that you must not have already known this. And if it's hard for you, chances are it's hard for everybody else as well. The technical and philosophical complexity is such that it is always going to be limited. We have struggled maintaining even LCSH. Library's been working on that for a very long time, and yet it's far behind, and it expresses only very simple relationships. And when we're talking about RDF, far greater complexity. I mean, who's going to do that? And then, of course, search and archiving. We've already described that, how you can't, stem an identifier search. You can't. Identifiers are very discrete things. It doesn't allow you to. It doesn't build any fuzziness, and the archiving is very different. You have to figure out ways to how to deal with it. So one of the things I would suggest is that as libraries use RDF more and more, the change will be very evolutionary. And in fact, some of the very specific changes that Michael Heaney recommended in 1995 are actually being deployed in OCLC. You'll see the identifiers in there, and the idea is that over time, you're going to have more and more systems that understand these identifiers, and eventually they don't need the text string at the beginning. I would not expect it to take over the world for a lot of reasons, mostly due to the complexity, and also that it's really not the right tool for everything. The RDF, when it's really implemented well, people will be able to use it without even, not only without knowing RDF, but without even knowing what it is. For example, you do not need to know HTML, CSS, or JavaScript to use the World Wide Web. You just use it. As a matter of fact, you don't need to know any of those things to be a webmaster nowadays. Now, in 1995, when Michael Heaney wrote his article, there were two browsers, two main browsers as far as I remember. There was Netscape and Mosaic. And while there were some primitive HTML editors, by and large, everyone wrote their HTML by hand. Fast forward, people have all these content management systems that don't even let you write HTML. They don't even let you write JavaScript. Likewise with RDF. The sensible thing for it to do is for it to be working in the background. It becomes a technical infrastructure detail. That's all I have. I hope you enjoyed the presentation.